Okay, in this video, I'm going to demonstrate an amplifier. Uh, this amplifier is a simple design. It'll do about 30 watts into an 8 ohm speaker, and that's 30 watt RMS. That's if you use the 24 volt power supply, dual polarity 24 volt power supplies. And I also made a little plot here of you can run this at lower voltage. So I have it running at +3 and -3 all the way up to +24 and -24. Now everything on here is written for the plus and -24 supply. Um, these changes, I changed R1 when I lowered the voltage or adjusted the voltage. I have different values that kind of optimized, and I left R2 alone. But later I found at the lower voltage settings, R2 probably should be lowered, and then you might want to tweak with this. This is more or less for the DC offset. So when you ground it here, you just try to minimize your DC here because it'll put it. Then you don't want any DC going through like a speaker as much. You want to minimize that, so you can trim that, and that's if you lower this. I mean, you don't have to, but what I'll show you what's happening here. If I put my mouse here, or let's put the AC on. Okay, so we're going to put an AC 40 hertz signal, and there it is. You can see the crossover distortion. That's from here. But if you look at the output, it's kind of amazing because it's pretty clean, and that has to do with feedback and gain. I've read about that before. I'm not sure if I know how to explain it exactly very well, but you can probably find that online. So if you're fine with that, then there's no need to change it. But what's happening here, the diodes, because I didn't change this resistor at the lower voltage setting, I didn't reduce it, these diodes aren't turning on really. So I'll show you what happens if I lower this value, let's say to maybe 2K. Let's try 2K, see what happens. Okay, see how it cleans that up a bit? And then it lowers that, so it does affect the gain a bit. Of course, we don't have a lot of signal coming in here. We've only got 7 millivolts coming in. So we can also, and it's shifted the DC. To mess with that, you could go over to this resistor, right, click on it, and I think you gotta lower it. Let's see what happens when I lower that. Yeah, it's coming up. Let's go a lot lower, actually. Let's go down to maybe 3 or something. Oh yeah, see? Let's go down even lower. We did 2.5. So that might sound because they kind of tweak this a little bit. Yeah. Okay, so you get the idea. Let's see if I can go down. I bet you 2 is going to be really close to having that centered. 2. Yeah, pretty close. And we're probably overdriving it a bit too now. So we got to go down here and maybe put this at around 5. Let's see. Yeah, it's a little less. So you get the idea. You can kind of center that. And then I can also, let's go turn this. I can also test it when we ground it. So I've got this pull down resistor, and you should leave that in because if you take it out, this will jump because this is open. And let's see now if I have a ground. So there's about maybe about 192 millivolts going through your speaker. Now let's if I ground that, what happens? Yeah, it's a little lower. Okay, so keep in mind that does affect some of the DC there. I mean, it's not a high performance amplifier, but it'll probably sound pretty good for a lot of stuff, and it's good for amplifying DC. This is like this stage. I sort of did this design for driving a speaker, right? These are Darlingtons. I don't know the actual part number, and the software doesn't tell me. These are all 2N 3904s and 3906, depends if it's PNP. This is also a Darlington here. Yeah. And so it'll probably work with most power Darlingtons. Just rate them so they can drive enough wattage. This is going to be running 30 watts at max. That's at max. And right now, our standby current worst case scenario is 4 milliamps with the 3 volt setting. Let me see that. Yeah, that's what the worst. Okay, now let's jump up to the 24 volt setting. Let's change these to 24 volts. 24 volts. Okay. Okay, and let's make this one 24 as well. 24. Okay. And let's put this back to where it was, 15K. That's how I had it all set up before. It's K. And I also changed it. See, I have it 13.3 meg here. We'll just change that. I mean, it'll run with quite a wide range of settings, but if you just want to have it tweaked a little bit better, it's better to do that. See, I got my DC down a bit there now. It should be around 0. So, yeah, so we're ground. What do we got here? 4 millivolts sitting there. That's not bad enough. Unconnected ground, and I was just grounding through the 1K, 100K. There is a difference, right? And now we're pumping in a bit of DC to our speaker. If we have a speaker there, it's about 300 millivolts. Okay, so I just want you to be aware of that. Now, if we have music attached, that's what we're going to get here. We're going to get the sine wave here. And let's crank up our juice here. I think we can go as high as about, let's see if we can go to 2 volts. I'm not sure. It depends on this gain. This is your op amp gain here. So this is set to 995K over 5K. So that's pretty high gain. I think that's a gain of 200. And then plus 1. This is your positive non-inverting input. So 201 gain. I can really lower this, right? Probably 0.05. Let's see what that does. Okay, you can go a bit higher. I'm not really calculating anything here. I'm just trying to go kind of quick. And let's see what that is. So that's getting pretty close, I think, to the rail to rails. I mean, it doesn't go right to the 24 volt rail. It might go a little higher than that if I go up a little bit more. Let's see if it'll go a little higher. Let's see if we can go to 130. See, it's starting to clip here already. So you're roughly in that range of, if you got the full gain here, you can't really go much more than maybe, I don't know, maybe 110, I think. I think that's what I remember. Okay, yeah. And you can see we're even this driver's stage here, it's starting to clip too, but doesn't look quite as bad in the output. Maybe it's just the scaling, but we're still driving it too hard. So let's come down a bit more, maybe to 100. Let's see what that does. Yeah, we're still overdriving it. Gain is set really high. That's why. I guess maybe 90. It's getting pretty close to sine there, and it's getting better there. It's just dropped in amplitude a little bit, but you get the idea. These are actually kind of working now, and I'll tell you how you can tell. I've moved this off and put the ground here. You can measure the DC 1.182 there and minus 1.169. So yeah, you've got close to 2 point, little under 2.4 volts, and that's fine. These are Darlington; they'll take a bit more. So I put 5 diodes in, and and then I just ran it. You can adjust the current flow through the diodes. Okay, so that's about all I want to show. You can use this to power, like, drive a speaker. You can use it at the various voltage settings. You can do a little bit of tweaking. I used a free program online to simulate this. It's called falstad. You can go to just, I'll put a link in the description on the bottom of this YouTube video, and you can use it for free online. You can actually download it to your computer too. It's a JavaScript based simulator. It's good for stuff like, I know these are the oscilloscopes they have kind of with it, right? And it's good for maybe audio. And after much above that, the oscilloscope just can't handle it. I'm not sure why, but maybe, I'm not sure if you can do RF circuits with it or not. Like, but I know the scope wouldn't really help you there for the RF, but maybe you can get the voltages, because you can see the voltage with you. Like here, I've got the voltage that are showing the amperage, and you can set voltmeters and stuff like that. There's all these. If you right click on it, you get all these options. You can, you can add things in. But there's instructions online too, on the falstad website. So go check it out. Thanks for watching. I hope this has been helpful for anyone. And one thing also I should point out, you can amplify the DCs here. So this is 0.1 volt. What do we get if I put that in? Am I too high? I might be too high there. Let's go down, edit, and let's just put in 20. It's 20 milli. Is it going to be enough? Yeah, so that's in the range. So if we put 20 in, we've got a gain of about 200, I think. 200 times 20. Yeah, it's 3.9. So it's about right. It's getting a little under maybe, but you know. Anyway, thanks for watching, and I'll try to get some more other designs, either amplifiers or other electronic circuits on. All right, thanks for watching.